Anytime we multiply expressions with the same base, we're supposed to keep the base and add exponents. So I'm going to keep the base. Okay? And I have negative 3 plus 3 plus 5. I can add these two fractions because I have common denominator. 3 plus 5 is 8. 8 divided by 2 is 4. That's why I'm going to have minus 3 plus 4. This is equal x. Minus 3 plus 4 is 1. X to the first power is x. This is the solution to this problem. Let's take a look at the second example. Anytime we have parentheses between the numbers or variables, there's like invisible multiplication sign. Okay, I'm going to make this multiplication sign visible. I'm going to rewrite this problem as a b to negative 1/3 times b 5 over 3. B and B, I have the same base. Anytime we multiply the expressions with the same base, we're supposed to keep the base and add exponents. That's why I'm going to have a b minus 1/3 plus 5 over 3, which is equal a b minus 1 plus 5 is 4. 4 over 3. This is the solution to this problem. Let's take a look at this example. I'm going to do exponents first. I have to keep the order of operations. Exponent is supposed to be done first in that kind of problems. I have 3 and I'm going to multiply external exponent by the internal one. Okay, so I'm going to have y 2/3 times negative 9 over 1. I converted 9 to the fraction because I have a fraction next to y. Anytime you multiply fractions, you have to try to reduce any numerator with any denominator. 3 is divisible by 3 and 9 is divisible by 3. That's why I'm going to have 3y 2 over 1 times negative 3 over 1. Positive times negative gives me negative. 2 times 3 gives me 6. This is 3y to power negative 6. Now, because I have negative exponent, I'm going to convert this expression to fraction. Okay, in order to convert negative exponent to positive, I'm supposed to bring y to negative 6 to the denominator. My solution is 3 over y to the 6th.